Dear friends, welcome to Infos. Welcome to another video from Oil and Gas Training. In this video, we are discussing about a new subject. In fact, it is not a new subject, it is a part of a control system, distributed control system. Maybe you remember my instrumentation module, control valve module, normal valve module. So we have already studied various instruments using in the field and the signal, how the communication between the control room operator and field instruments, how the control system is working. Some information we have already studied in our previous various videos. In this video, we are discussing about the total control system, using how to control efficiently and effectively in a process control, in a process plant. So welcome to this video, distributed control system, or DCS. A distributed control system, DCS, is a digital automated industrial control system that uses geographically distributed control loops throughout the factory. You can see here the first in the bottom layer, the field instruments. In the middle layer, there is PLCs and other control panels are there in near the control room. Near the field is called, normally called LER, local equipment room. And in the third layer, in the top side, we have graphical user interface and or HMI, human machine interface, is there. That is the control room. So we will discuss in three the constructional details and features, and what are the different type of DCS, how it is working, etc., etc. We will study in this video. So that DCS is a digital automated control system that uses geographically distributed control loops throughout a factory or machine or control area. The goal of a DCS is to control industrial processes to increase their safety, cost effectiveness, and reliability. This is very important. So before DCS, earlier manual control system was there. When the science and technology is improving and the various new systems, control system, how to control the process plant, minimize the risk, hazards condition, and increase the effectiveness of the plant. So that's why a DCS or electronic type control system, or more important process instrumentation systems came to the plant, and it is using for the increase their safety, cost effectiveness, and reliability. A control system is a set of mechanical or electronic devices that regulate other devices or systems through the use of control loop. So control loop, already we have discussed that one in our previous instrumentation videos. Control loops are systems composed of all the hardware and software control functions needed for measurements and adjustments of individual process. Control systems are a central part of a industrial process automation system. So it's clear that the DCS is a system of sensors, controllers, and associated computers that are distributed throughout the plant. So sensors and field instruments in the bottom layer, you can see various field instruments like switches are there, control valve is there, sensors are there, transmitters are there, shutdown valves are there, various other instruments are there. So controllers means mainly programmed logical control, or PLCs are there, and like communication bus bar is there, communication link is there, and controllers itself have some computers are there, etc., etc. So many instruments and control system software, etc., are included in DCS. Each of these elements serves a unique purpose of such data acquisition, data collection and acquisition, you can say better, process control, as well as data storage and graphical display. So, main area of serve purpose is data acquisition, process control, as well as data storage and graphical display. These individual elements communicate with a centralized computer through the plant's local area network, often referred as a control network. We can say a total control network. As the central brain of the plant, the DCS makes automated decisions based on the production trends. It sees them in a real time throughout the plant. So it can take some automatic decision based on the set point or predefined set point or predefined logic. It can take some automatic action without interference or intervene or without the involvement of operator. As an example, the DCS at a power plant might automatically increase steam generation capacity of multiple turbines in order to keep up with changing demand for electricity during hot summer days, and then decrease it as outdoor temperature cool overnight and demand decrease. Simple example, when the DCS system is increasing the temperature or production capacity or production in the steam turbine when the summer time and winter time it is reducing or decreasing. So these are simple example how DCS is automatically taking some decision. It is not actually automatically taken decision, it is a predefined values and set points are there. So according to that one, it is action is taking place. Whereas a PLC could adjust a single unit operation, the DCS can make adjustment of each of a plant may interacting unit operations. So PLC we will discuss in detail. PLC is also part of DCS. So that we will discuss, but PLC has some difference. Don't compare, PLC is not equal to DCS, but PLC and DCS together joining in a family for a control system. So we will discuss PLC in a separate session. DCS are used across the process plant industries to supervise complex production processes. They are more widely deployed at large continuous manufacturing plants such as those in the oil and gas industry. It's very clear. With the help of a DCS, these and other manufacturers can efficiently coordinate adjustments in a top-down fashion using a centralized network of computers and other control systems. Instructions from the DCS are deployed throughout the plant and fed into individual controllers. Clear. So from the control room, the instruction going to controllers and controllers to the field, and reverse also from the field to control local control room, then to CCR, central control room. When configured appropriately, the DCS can improve safety while also enhancing production efficiency. These 2 points are very important. Improve safety or minimize the risk and hazard, and enhancing production efficiency. How does a DCS, distributor control system, work? DCS are made up of control elements distributed throughout a plant or factory. These control elements include computers, sensors and controllers we already discussed. Each element serves a specific purpose such as data collection, data storage and process control. This is very important. Having the control system architecture distributed around the factory or plant provides an effective control, efficiency and process quality strategy. This is also important, process quality strategy. Additionally, if a piece of DCS architecture fails, the plant can continue to operate. It's very, very important. In case due to power failure or any other abnormal issues, in case DCS failure, a plant can continue to operate for a certain time we can continue to operate without any further abnormal issues. That is also one advantage. For this reason, DCS are commonly found in industrial field and processing or manufacturing plant. A DCS is functionally similar to supervisory control and data acquisition SCADA. This also we have to discuss. We will discuss in detail in the coming videos. So it's a SCADA also using for another control system for industrial control. Applications, you can look at to the picture in SCADA. Some more information. DCS is not equal to SCADA. SCADA and DCS are different, almost similar, but they have difference, large difference is there in SCADA system and DCS system. SCADA systems are used in power plant, oil and gas operation, refining, telecommunication, transportation, and water and wastewater. All where DCS is using, SCADA can also use, but there is some differences there. This is the one of the important and prime difference. They tend to be used in situations where the control center has more remote location. The location, oil and gas, example, oil and gas production field is taking lot of remote locations are there, and data coming from different remote location. In a refinery, you are taking a gas treatment plant, you are taking, it's a only one plant or two plant or three plant you can configure or connect, interconnect that one. In that case, DCS is best, but kilometers a plant, remote plant is scattered or distributed, or it is remotely located, means then maybe SCADA will be more suitable. You can see here the instrumentation input is coming from the field to remote terminal unit. Instead of local equipment room, we call it as a remote terminal unit. It's the same as a local equipment room, but it is each remote location we need a separate local equipment room, better to call as remote terminal unit. And from there, and the communication to the HMI, human machine interface, that is a SCADA operator terminal, radio and cellular telemetry technology is using for the communication between LER and or RTU between and SCADA or between the field. So some major difference is there in SCADA operation than DCS. So DCS is not similar to SCADA. That is important one. We will concentrate DCS on in this video, and SCADA and PLC we will concentrate, or we will definitely will make another video. SCADA has some more information to provide as a overview. A SCADA system is a combination of hardware and software that enables the automation of industrial processes by capturing operational technology real-time data. So SCADA we can define in this way. SCADA connect the sensors that monitor equipments like motors, pump, and valves to an on-site or a remote server. And some overview is also included in this one to clear that one before going to DCS, PLC and SCADA. The primary difference between a PLC and SCADA is the technology. For example, a PLC is a physical hardware where SCADA is a software. This is the very, very important information. PLC is a physical hardware, whereas SCADA is a software. This means that a PLC can pick it up and physically inspected, whereas the SCADA works on a computer system and is comparable to that of an operating system like Windows, for example. So SCADA is a software which connects to the PLC. So without PLC, SCADA cannot work. So PLC is also included in the SCADA system in RTU. PLC is installed in the RTU, or in the field itself also sometime PLC can install. So PLC information coming to SCADA. How a DCS is structured. So this is our core information on this video. A distributed control system includes both software and hardware elements. See here, Both software PLC and software also included in DCS. This installation of most controllers locally keeps cost low. On-site automated control improves the reliability of the system, and human oversight is enabled for central control functions and remote control options. So this is the and human oversight is enabled for central control function and remote control options. Individual processors have their own controllers with a separate central processing unit CPU to so other processor can continue if individual system fails. That also possible. It's a separate different control systems are there in the each processor. So one fail also we can run or the other system will continue to work. The architectural design of a DCS system. Number one, an engineering workstation. This is a supervisory controller for the DCS as a whole. The station typically includes configuration tools that let the user complete functions such as creating new loops and input and output point, IO point, as well as configuring distributed device. Around this area is called engineering station. This LER is called engineering station. Some part may be in the CCR also included, but core area is in this area, LER, local equipment room. An operating station mainly in the top area, human machine interface, HMI. This station is used for operation, monitoring and control. That is the operating station where the panel operator is sitting, commonly called central control room or central control facility. A process control unit, this microprocessor based controller is designed for automatic and compound loop control. This is also part of LER. A communication system, that is the data transfer. This system brings data from station to station and is important in distributor control system. Typical network protocol used like Ethernet or Profibus and DeviceNet using the communication. In a DCS architecture, sensors gather process information which is sent to a nearby IO module. IO module is located in LER, local equipment room. The data is moved to a process control unit as well. Smart devices, some field devices are digital smart devices, if used, can also send the data to a process control unit directly. The data is then further processed and analyzed to produce an output result. The processed output is based on control logic used, predefined set point, predefined logical value, which is the part of a program, that control program operation. That is sent to a moving actuator, to the control valve or actuator or motor to start or stop or etc. using another bus, and then the commissioning process occurs. This is where instrument and control systems are verified and documented, and where the control logic and implementations are transferred to an engineering station for the operator to view. So operator we can view here and command here, edit here something. He can monitor and control. The operator send control action to operator station. These devices in this process can be divided into the following 5 levels. Various level of operation we can summarize. Level 0 consists of field devices like sensors, transmitters and other control element in this area, the field area. Level 1 is the IO module and processors in this area. Level 2 is the supervisory computers that collect data from processor node, that also part of here, LER. Level 3 focuses on the production control level, monitor production here. And level 4 includes production scheduling, part of the CCR and pre-programmed planning and scheduling operation. What are the challenges, advantages and challenges of a DCS? Distributor control system provide following benefit. Number 1, complex structures. So different type of complex structures they can manage, unlike comparable Programmable logical control PLCs, a DCS can assess large amount of information in a complex environment. This is very important. System redundancy. If a processor fails, the redundancy provided in the DCS ensures that only one section of the planned processes is interrupted. So other system will be normal and it will continue until the issue solved. Scalability, more controller process unit can be added whenever needed. This is very important. Adding more I/O modules to a controller also extend I/Os, input output devices. So the scalability is there in DCS system. Security also very important. Security and cyber security capabilities are enabled at the higher engineer level and operator level. Some downside of the technology includes situation where failure of the one controller acts more than one loop. DCS versus PLC, some overviews. I have added some overviews on both. PLCs are another type of industrial control technology. They are small modular computers with customized instruction for performing a particular task. That is very important. They are small modular computers and customized instruction for performing a particular task. Like DCS, PLCs are using in ICS industrial control system for a variety of industry. A PLC controls individual devices while a DCS can control multiple machines or process in a plant. And while PLCs are designed to replace mechanical devices like mechanical relays, DCS are able to control entire factories and process plant with many interconnection systems. So this is the picture is provided here is a typical PLC system. Input is there and control system, control unit is there, CPU you can get and output device is there, and you can interconnect with using a computer. HMI device is also there. DCS installation system, somewhat information is also available for review on your study in a central whole DCS system, how it is structured using a pictorial representation. Number one is field, you can see in this bottom area, and somewhat in this area also in the field devices, transmitters, control valve, switches, marshalling boxes are installed in the plant or field, you can say, to measure each type of process variable such as pressure, level, temperature and flow, and a dedicated transmitter is installed. Many transmitters are installed in the field. These transmitters are installed on the pipeline, vessel or rotating equipment. And LER is the field information is gathering in the LER, and some decision making process is taking place in LER as well, and communication is sending to operator station as well also. So LER is very important. LER is local equipment room. LER is situated in the plant in a safe area. Mainly DCS in LER contains. So DCS is also involved in LER as well. The following: marshalling cabinet, intrinsically safe and non-intrinsically safe. IS barrier cabinet from transmitter inputs and outputs. So IO module, input output modules to control valves, both are there, input module and output module. Input module is coming from the field, output module is going to the field. DCS cabinet, analog input output, digital and digital input output card, multifunction process card, more card. Optical fiber cables, that is a communication cable, redundant, two pairs working together. CCR, central control room. CCR is operated by the panel operator who is responsible for monitoring and vary the parameter and production and initiate shutdown as appropriate for the production and the safety of the plant. So from this information you can see three categories, the three important parts are there in a DCS system: field instrument, LER instruments and central control room facility. We will just have a detailed look of this three information in more information available. That is, let us discuss that one: field devices, Transmitter sense the process variable, then convert into a process into a meaningful output such as 4 to 20 milliamps when we are using a digital or electronic transmitter. Pneumatic transmitters are also there, but nowadays most of the modern plants are using a digital or we can say electronic transmitter. So it produces 4 to 20 milliamps equivalent to the field information. Such such signals pass through the marshalling box installed in the field to the marshalling cabinet installed in the LER. These informations are very clear. To control such process variable, dedicated control valves are installed in the plant. So, in the field there is another control valves are also there. The plant in the pipeline, control valves receive 4 to 20 milliamp signal from the controllers installed in the LER through the marshalling cabinet, then through the marshalling box installed in the field. So, control valve is receiving the signal from the controller from LER through some other supporting devices are there, like I2P is there, positioner is there, solenoid valve is, many informations are there, but in general we can say control valve receive 4 to 20 milliamp signal from controller. So that is important. Controller is a electronic controller. Control valves are mostly being pneumatic signal. This is important. An electro-pneumatic converter called I2P or transducer is installed in the field that convert 4 to 20 milliamps signal to 3 to 15 psi to pneumatic signal to the control valve positioner. So this information already we have discussed in detail in our various instrumentation module. I request you to watch that module. Will get a detailed information. Here is an overview of how it is working. Switches such as pressure, level, temperature and flow switches are using for in alarms, producing alarms and trip conditions are installed for the process, and they provide the pre-alarm and shutdown at the set value as necessary. So these are also in the field information. A transmitter plus controller plus control valve provide a closed control loop. This is very important. Whereas the switches provide the safeguard. This is the very important. A control loop is there and safeguard system is there to the plant in the event of a failure of the control loop. Now let us discuss on local equipment room. LER is situated in the plant in a safe area. Mainly DCS in LER contains following. These are the LER contains the item marshalling cabinet, intrinsically safe and non-intrinsically safe. IS barrier cabinet from transmitter input and output to control valve. DCS cabinet, analog input output digital input output card. Multifunction process card, many more card. Optical fiber cables, redundant two pair working together. The DCS in LER is the heart of the DCS system. So DCS in LER is the heart of the whole DCS system. The controller situated here calculate the error between the set point received from CCR against the field transmitter signal. An output is sent to the field control valve to correct the error signal. Digital signals from the switches are verified against the predefined logic. This is also doing in LER. There is a redundant optical fiber network data highway we can call between the LER and CCR. A high data speed signal is transmitted through the optical fiber cable communication and in unidirectional both way from LER to CCR and CCR to LER. Field information is continuously sent to the CCR for display, and the demand signal set point set to the CCR is received on the control memory. So both way it is communicating. Field information continuously sending to CCR and set point and other information receiving from the CCR to take necessary action. A fault diagnostic is continuously monitored in the DCS. In the event of total power failure at CCR, still DCS in the LER will continue to monitor and control the process. In case of power failure in CCR, DCS in LAR will help to continue the plant until the power failure issue or any abnormal issue to be resolved. If the power supply in the LAR is failed, the UPS uninterrupted power supply would support the required power supply to LAR DCS. In case there is a total power failure, remote chance to the DCS in LAR, then the plant will totally shut down and all the ESDV emergency shutdown valves will go to the fail safe condition either to open or close, example, or inlet SDV to the separator would close, or vent SDV would open and rotating equipment pump and compressor will shut down. CCR is the one more facility included in DCS system. Let us see what are the information available, what are the facilities is included in DCS CCR system. CCR is operated by panel operator who is responsible for monitoring and vary the parameters of production and parameters for production, initiate shutdown as appropriate for the production and the safety of the plant. So he can see the plant layout. In the plant layout, you can see the overview by equipment wise like separator, heat exchanger, stripper, pump, etc. See the alarm, see an alarm and alarm summary in a day wise, hour wise. Any override done on the PLC metrics panel, any override for the maintenance work, inspection work, etc. That also he can see in the CCF operator. Trend of a loop over a real-time graph. He can see many trend and graph. Moreover, can read the following for every loop. The operator who is sitting there, he can read the following every loop. What? Process parameter, pressure, level, temperature, level, etc. ESDV, control valve, open or close. He can always monitor whether the position of control valve and SDV. Start of the equipment, pump, compressor, run, stop. He can do various rotating equipment. Alarms, he can see pre and shutdown alarms in the time to time receiving with the audible and visual. So he can see the alarms and he can take necessary action. Can change of a controller on the following. He can do some changes as well on a controller. The set point rise or lower to manipulate the process variable. He can change the set point in some extent. He can do that one. Take auto and manual. Take the controller to manual in case of a shutdown and startup is taking place or any abnormality coming that one or any maintenance activity. He can make to auto and manual option in a controller. Close open control valve manually. He can do a control valve to open and close due to some maintenance or startup or shutdown. He can do that one. Can initiate start. So he can do some activity from field activity from control room. Pump he can start or stop. Turbine he can start or stop. Or compressor he can start. Ultimately he can start any rotating equipment like ID fan or blower fan, motors or something. He can do the rotating equipment start stop according to the situation. Can initiate shutdown of the plant in emergency coming and he can initiate a shutdown from the plant. Partially he can shut down unit by unit or full also he can do, a panel operator. He can print or he can take some reports for the general reporting purpose for the higher management or the seniors for the performance to view the performance of the plant. Alarms he can print. Parameters also he can print various parameters controlling on the plant. Status he can print. History he can print. Thanks for watching this video. We have discussed a DCS system in detail and PLC and SCADA only overview. Hopefully we can add more videos on control systems and SCADA, PLC and DCS system in our coming videos. Thanks for watching this video. Have a good day.